Hello campers, let's do electrical energy video number 8, electrical safety in the home. So electricity is dangerous if you don't know what you're doing, and so domestic circuits contain several safety measures because things can go wrong, and in the early stages of using electricity a lot of people had mishaps with it, and so a number of safety measures are incorporated in just about every home. One of the first things that happens is we have an earth. So if you have a live wire and a neutral wire, and if you plug something like a kettle in and the element broke and it just happened to touch the outside of the kettle, if you went and touched that kettle, you would be effectively touching the live wire, which is the one that's carrying all the voltage. You'd be touching that wire, and the current would then flow through you and into the earth, and you'd be shocked, and you may well die. And so what most appliances have is that you have a 3-point plug, and there's an earth. And if you walk around your house, you find somewhere outside your house there's a wire coming out of your house, and it's attached to a metal stake somewhere, and that's your earth. And you can get these little things that you plug into your power points, and they will let you know if there's any earth leakage in your system. And I think the electrical companies give them away for free. And so how that works is, if you have the same situation and you got your kettle and the element breaks and the piece of metal that's the element touches the metal, what will happen is there'll be a sudden burst of current, because it will still flow to the earth, but instead of flowing through you, it goes through the earth wire. This is assuming that no one's touching it at the time. And the fuse will blow, and then your kettle won't boil, and you go and fix the fuse, and you work out that your kettle's not working anymore, and so you replace your kettle. So that can save people, and it can save houses from burning down and things like that, because it could be your kettle, it could be your dryer, it could be your toaster, it could be your hot water system. If there's a sudden surge of current, the fuse blows, and we'll talk about how they blow in a sec, like right now. And so in your house you have fuses, and the fuses are rated for different currents, and they're designed basically to melt if they get too much current through them, because they get too hot and they melt. So this fuse is rated for 3 amps, so when it's got 2 amps going through it, no problem. But when it gets 10 amps through it, it gets too hot and it melts, breaks the circuit. Now these are old ones, and that's what they look like. But you might have these ones in your home. If you go and look in the fuse box and you've got a moderately old home, you've got ceramic fuses which just have a piece of wire across there. That's what my house has, and if things stop working, you go and check all the fuses, and then you've got to manually replace one of the wires. And that's a domestic fuse. Fuses are used in lots of things. Cars have fuses, and this is a fuse out of a car. Again, it's all designed to, sometimes fuses are designed to save other components in the circuit, or they're designed to save human lives, or to save the building from burning down, things like that. Okay, but the trouble with fuses is, even in that instant when the fuse melts, there's a big surge of current, and that current is enough to kill somebody. Even if it trips and does burn the fuse, there's enough current to actually do a lot of damage. And so nowadays new houses have to be fitted with a residual current circuit breaker, or an RCCB. And if you've got a newer home, or if you've got an older home that's been rewired for one reason or another, and you look at your fuse box, you'll find something like this. And also you'll find that all the fuses have been replaced by circuit breakers, which look like this as well, but not as bulky. The difference between a circuit breaker and a RCCB is a circuit breaker is just basically a fuse. If too much current goes through it, it trips the switch, and you have to go and trip the switch to get the current to run again. A RCB, however, has a little internal mechanism in which as soon as it gets a surge of current, it trips, and so it stops that current flowing massively. And so this would be wired into the circuit that contains all your power points and probably your light switches, but usually just your power points. And that's the internalised. It's got a little electromagnet and it trips automatically. It doesn't need any batteries or anything. It uses the current that's flowing through it. And another way of having safety in the home is what's called double insulation. And so some appliances don't have an earth wire, so they're the ones that don't have two prongs. And so when they're built, they have to be built with what's called double insulation. So all parts that you can touch are either plastic or insulated, and there's no live wires that can readily be touched, or that you could accidentally hold, or could actually break and then touch something that you hold. So something like your clothes dryer, your hair dryer, your electric toothbrush, things like that, are all have that as their safety measure, double insulation. Now in the next video we'll look at power and energy usage. See ya.